All right, this will be for making the pipe flange. Now, this pipe flange is going to have a fair bit of design intent built into the way that we're going to make it. So the drawing is telling us a good bit of design intent. For instance, let's look at this, where the set series is going to go. There's this raised area. It's a raised boss. It's got a threaded hole through the center of it. So it's 0.625 inches in diameter, and it is raised 0.1 inches from the cylinder surface right here. You can see there. And now we're told it's going to be located at the center of the cylinder. So notice it's aligned in the center of the cylinder, both like horizontally and vertically. And we're told the distance here, which it would be 0.75 and 1.5, because this is 1.5 inches in length, and then the diameter of our cylinder is 3 inches. So technically, yes, this is correct, but if we were to add in these values instead of constraining it a specific, then bad things can happen. I have an example model on Canvas for which is modeled in a bad way. It is this one right here. It is the pipe flange bad design. This looks fine, right? This looks presentable. But when you start to look at how it's been constructed, then things start to break down. There is a list here of things that to change. You can mess around with this if you want to. I'm just going to show you a couple of things. So we're gonna change the flange, this cylinder OD. That's what this means. To 3.25 instead of from the 3 inches. So I'm going to change this. I'm going to change this from 3 to 3.2. A totally acceptable change. Oh, this needs to be 3.2. Okay, let's change this. Now let's go and change the boss diameter to be 0.5 instead of 65. And we're also going to make sure that it's centered on the cylinder. Let's go back. Let's see. Find it right here. And notice that, well, remember we changed this diameter from 3 to 3.25. We would change this to 5. And then we'd have to come in here and change this to 3.25. So we would have to do. So some errors or something. Yep. I might have done it. I think it did. Threw some warning out at me. That's fine. But notice it. Well, that was a bit of a hassle. And if we forget that that needs to be changed, then well, there's going to be some issues. If I had forgotten that this does not automatically update whenever something changes, like the cylinder diameter or maybe the length, instead of it being 1.5, maybe it changed to 1 inch, something like that. The design intent is for this boss to always be centered on the cylinder. So we need to make sure that it is. There's a few things like that on here. Another one is this needs to be 1.5. The total distance is not 2. It is, but really this is 1.5 from the base flange. The diameters here reference geometry. What's driving this geometry is actually the fact that we have a 1/2 inch spacing from the center of the hole. Let's go ahead and get started. We're going to open up a new file. This is in inches. We're going to call this pipe flange. Make sure we're saving it to a location that we can access, and we'll say OK. Make sure that we change our role to advanced. We'll start with the sketch. Now this is a cylindrical feature, or cylindrical part So we'll essentially be, we're going to use the revolve tool. We're going to sketch essentially half of this and revolve it around the center axis here. So we're going to sketch this profile here and revolve that around. We'll leave do have an edge plane. We do have a round here. We're going to leave that till after. We could add that in here. We're not going. So actually I'll sketch on the right plane. And I'm just going to sketch out, that outline. So I'm going to go profile, start at our origin, and I'll go out and then up, over, up, over. And we want this to be a corner here, so I'll go past it. I'll hit escape. Now I'm going to start another line at the origin. I'll go straight up past the line we just made. So we have an intersection point. And then exit out of the profile tool. I'll go to my corner tool here, and I'll select the lines that corner. And there we go. Say close. And there's my basic profile. It's a little large, but that's fine. And we're gonna make a couple of expressions before I start to add in some values here. I do want to make an expression for the cylinder diameter. So for this cylinder diameter here, I also want to make an expression for the base thickness, and then also this what I'll call the cylinder thickness. So if we go back to our drawing here, essentially we're doing this 3 inches, so this cylinder diameter here, and then also this 0.5 and this 0.5. So I'll hit Control E to open up my expressions. And we're going to make 3 expressions. So the base thickness, so I'll say base thickness. That'll be 0.5 inches. I hit enter. Then we have cylinder thickness. This will be 1.5. And then we also have our cylinder diameter. So cylinder diameter. And that is going to be plus 3 inches. And I'll say, I was just hitting enter between each of those. You can hit apply. Say, said OK to make those permanent. I'll do the cylinder diameter first. So I can either click on like this line and then this line to bring up this distance here, or I can just click on that line to do the same thing. Now this is the diameter, so the length of this line is, so if I were to put in like 3 inches for this, whenever I revolve it, remember it's going to actually be twice this amount. So essentially we're putting in the radius here. So I'll left click on this, bring up the actual distance. I'll right click, I'll say add/remove expression. And then I can start typing in cylinder diameter. But remember that this is actually going to be half of the cylinder diameter. So I'll do cylinder diameter divided by 2. Now, whenever we did the expression, I didn't want to do, I could have done 3 divided by 2. For that would have been fine. For me, I like the expression to where I can just put in the cylinder diameter and then actually do the halving that here in the sketch. So I'll say yes, I do scale it. Now there is something else that we can do with could have done for this. So instead of doing it that way, we could have And either way is fine. I'm just showing y'all this to show you. Um, so with NX, what I can do is I could have selected this distance here. And now when I right click on that line, I can say convert to half diameter. And now I can put in the cylinder diameter and it's going to half it for the distance. So it's also maintaining that 3 inches in diameter, but it's halving it because I did the convert. Essentially, I'm essentially saying convert to a radius dimension. Either way is totally fine. Add in the base thickness and the cylinder thickness here. Same concept that we did before. The only difference here is that we don't have to divide it by 2 because it is the length. The diameter was divided by 2 because when we revolve this, it's going to be doubled. But when we revolve this shape, this distance here is not going to change. It'll just be revolved around axis, but it's not like this is going to double in size. This distance here, if we think about this being revolved around, essentially is going to be mirrored on the other side. So like from this edge all the way over to this edge is that total length, right? But here we're just describing this vertical distance. So that's not going to be double. So we can just simply add it in. Because we have an expression, I can right click here. So I click on the line, left click on the line, left click to bring up where we'd actually type in a value. I'm not going to type in a value. I'm going to right click and say add such expression. And here I can do these things. You don't have to do the add remove expression, but it does make it easier because it'll, like once you start typing the expression, it'll automatically pull up what the expression that you are actually using. So like notice here, we called the cylinder thickness, right? So cylinder thickness. So it pulled that up, but I had to type out the whole thing. Whereas with here, I just started to type out base and it automatically base thickness. Expressions here make it easier to change these values later on. So that's why I like using expressions. Sketch is partially defined with 3 movable curves. It's partially defined because of this right here. We don't have a value for this. If we look at our drawing, we are told values. But so this is like the edge. So we're sort of looking at it from this perspective here. This is the edge of of the base. Here's the edge of our cylinder, and here's like the area that's can be moved in and out. We know that the 3 inches in diameter, so we've got that part. The two, or really the thing that we're missing the most is this 5-inch diameter. Where it's in parentheses though, meaning we can't use it. What we do have is these 1/2-inch increments here. Essentially what we're being told is this whole position is going to be 1/2 inch away from this cylinder. So if this cylinder wall were to change to 4 inches in diameter, well, the hole would still be 1/2 inch away from that. And the edge of our base flange is going to be 1/2 inch away from the center point. So essentially the size of the base flange is going to update based off of the cylinder size. It'll always be 1 inch larger in diameter than the cylinder. To add this in, we're going to go ahead and place a point for where the hole is going to be. So the hole is going to be, or one of the holes, so one of these holes here, this hole is always going to be at that point location. So we're going to go and add in that ½ inch. So from this point to this cylinder wall is going to be ½ inch. Fine. And let's select that point again. Make sure we're selecting the point. To this edge is also going to be ½ inch. Sketch is fully defined. We can go ahead and say finish. And we'll revolve this. We're going to revolve it. Make sure we have our sketch selected. We'll say specify vector. We're not going to select like one of our arrows. We will just select this center line. And we'll say OK. Now let's look at this raised boss right here. A couple things to point out. So one is that we have a thickness of 0.1 inches, but also it's making connection with our cylinder right? So we've got this connection. Let me see a little better here. See how it's flowing in. We do have an edge blend there, which is sort of helping smooth this out. But this line, this vertical line, continues on to the cylinder. Also, it is centered on the cylinder. So this 1.5 and this 0.75 reference geometry, cannot use it to actually position this. But that's fine. We can actually use our constraints. To make this though, we want to sketch like on this cylinder essentially. So we don't really have a surface to do that on. So what we're going to have to do is we're going to have to add a datum plane. Datum planes can be added into our sketch or into our model and it gives us a surface to model on. So if we come up here to datum planes, right next to sketch, we have this little drop down, right? We have datum plane, datum axis, datum CSYS, datum coordinate system. The datum coordinate system is, what we're used to, right? It's datum coordinate system has 3 axes, so X, Y, and Z. 3 planes, so we have like the ZY, the XY, the XZ plane, and then it has an origin, right? It has an origin. We technically could use that, it would work, but what we really just need is a datum plane. We don't need any axes, we just need a datum. So if we go to datum plane, this window is going to pop up, gives us a few options for how we actually create a datum plane. What's really popular and helpful to use for some things is the bisector. We will use the bisector later on. Bisector is really nice. So let's say that I wanted a plane right in the middle of these two surfaces. I could do a bisector. I could say between here and here, I want a datum plane. Boom. There is our datum plane. And this is just like any other datum plane, right? So, I could actually create a sketch on this plane, right? Do that. There's a lot of other stuff that we can do with that as well. It's helpful to have something center. We don't want a bisector. What I want is for there to be a datum plane that is sort of, making contact with this cylinder, but is perpendicular or parallel to the our data coordinate system. Looking through the list, I see tangent. Now I know tangent, thinking about tangent whenever we're doing a sketch, sort of makes one point of contact between a line and a curve. It sort of sounds like what I'm doing here. So let's see, let's go to tangent. And it's wanting us to select a surface. Let's select our cylinder surface. And that's pretty much exactly what we want, right? So the tangent constraint is really nice. It allows us to do exactly that. So we have a plane just making a point of contact with a round feature, and it's also vertical or horizontal. And what's nice about the tangent constraint is that um, we can change like what's being referenced. So I can I've already selected the cylinder, but if I select one of the planes as well, so if I do like um, the YZ plane, now I can essentially say, hey, I want this to be tangent to the cylinder, but I can also say, be like 45 degrees from this reference plane that I have. I could say I want it to be perpendicular or parallel, always making contact with the cylinder. Tangent constraint is nice for stuff like that. The way that it was constrained at first, so this right here is exactly what we're looking for. Um, so I don't have to change anything else about this. So again, all I did was we went to datum plane, I selected a tangent datum, and then I just selected cylinder uh, base right there. And we can say okay. We'll create a sketch, and we want to sketch on the face of that datum plane that we just selected. So let's make sure that we select that plane. And I can say okay. Now you can sort of see like how we're sketching. So we're sketching literally on this datum plane. And the thing that we are sketching is our boss. So this 0.625 inch boss, 0.625. So we'll create a circle. And with that circle, have a diameter of 0.625. Now the circle is going to be, this boss is going to be centered on this cylinder. So I want it to be positioned so that if this diameter were to change, it's still going to be centered. So I can't say like 0.75 inches from this edge or anything like that, or I can't say um, you know, judging by everything about the thickness here, I can't say half this thickness, or I can't say 0.75 from this line. I have to reference something that is going to update and move this boss for me. And if we think about what we have here, we have this line. This line is actually being used to define the thickness of the cylinder, right? So we have a midpoint here, somewhere around here. We have a midpoint here, which is going to move based off of the cylinder thickness. Also, this line is always going to be at the center of the diameter of our cylinder because, well, it's the sketch, right? It's the center of the cylinder that's always going to be used. So what we can do is we can actually make coincident the center of our circle, right? We can make that coincident with the midpoint of this line, and that's going to achieve exactly what we want. It's going to uh, update everything for us. So I can say make coincident the center of our circle to this midpoint here. Make sure you do the midpoint of, it might be easy to, or it might be easier if you, um, so if you're looking at the sketch like this, it might be easier if you just kind of rotate a little bit so you can make sure that you make select this line. Not of this line. Don't choose the midpoint of the long line that's at the center. Right? We don't want it to be referencing the midpoint of the entire thing, just the midpoint of the line that's making the cylinder. So we'll say OK there. And our sketch is fully defined now. We'll say finish. And with that selected, we'll go ahead and extrude this. We go back to our sketch. It's extruding a distance of 0.1. So we say extrude distance of 1. Unite. Make sure it's uniting. Model. That's good. One thing we are missing though is if we look here, notice that it's essentially just it's at the sketch, right? It's not extruding like back into our part, which is, we want that. We want it to look like we want it to actually be coming from the cylinder. That's not achieved with just the edge blend. What we have to do is we actually have to change the start distance. So right now the start distance is 0, so it's starting like at the sketch plane. It's starting at the sketch and going whatever vector direction we have. We want to change this so that it's not starting at the sketch. We want to actually extrude some distance into our model. How much though? Well, again, like if we just put in a value here, it could theoretically change. This probably wouldn't change, but it could. So let's not just put in a number here. Instead, let's see if we can change something about like the value. So not value, not symmetric value. Maybe until next. Let's try that. Let's try until next. That's exactly what we want. So I want this to extrude out essentially until it meets some other surface. So if we look at what extrude next until next does, it says extrude to the next face along the direction vector. Boom, this is actually exactly what we're looking for. We just want it to extrude out until it comes in contact with another face. That's exactly what it's doing. So our start is until next, our end is a value, and it's a value of 0.1. It's uniting, and we can say OK. That's what we're looking for. Now let's go back and let's work on some of these holes. Let's do this 2-inch diameter through hole first. So this is 2 inches in diameter. It's a through hole. It's at the center of our part here. And we have a chamfer for the top, okay, not at the bottom, just through the top. So we'll go to our hole tool. This is a simple hole. Hole diameter will be 2 inches in diameter. We do have a start chamfer on here. Just make sure that we check mark the start chamfer, not the end chamfer. So make sure that we check mark the start chamfer. So 2 inches, we have a start chamfer. The specified point, we do not need to go to the sketch section because all we need to do is just pick up the center point of the top of our revolve. So, we have this round, we have this circle essentially right here. So this circle has a center. So if I approach the edge, remember it's best to do this if we're angled a little bit, looking down at it like this. The way I can approach the edge, and what we're looking for is that snap point. If it's really challenging to get, what you can do is you can come up here to snap point, and you can turn off everything except for existing point and arc center. And if it is hard to get, okay, you can come up here to your snap point options. All right, so your snap options, and you can turn off everything but arc center. All right, so really the only thing you'll be able to select is arc centers. So you're looking at the top of that arc there. This is a through hole, so our depth limit should be through body. And we'll go ahead and say show results just to make sure. Yep, it's good. So we'll say okay. Now our next hole, let's do so have this one here. This is a 1/2 inch. But the diameter is actually 0.562. It's a normal size hole for a 1/2 inch bolt. That's what this is. So when we specify this hole, we'll actually say is for the bolt of a 1/2 inch, and we want a normal fit. So, and next, so we'll go to our hole tool again. Simple hole. We don't want custom, so hole size custom. We want screw clearance. Screw clearance. Standards, ANSI, screw type, general screw clearance. Screw size is going to be 1/2 inch. The fit is normal. We do have a start chamfer and an end chamfer on this. And and again, we do not need to go to sketch section because we've already added in the point for our hole. So we're going to make sure that we pick up that point. Through body, yep. Let's see how this looks. Looks good. We'll say okay. Now on this hole, right, we're told that it's actually, there's 4 of them, right? So 1, 2, 3, 4. We're going to use our pattern feature for this. So we could, yes, we could have gone through and actually specified each hole location. But if that were to update, we'd have to go in and delete the points and add different points, or go into another sketch and do that. Not very efficient when we have our pattern feature. So if we go to pattern feature, now the feature that we want to pattern is our hole. Stuff like this, I have a hard time sometimes specifying what I'm actually trying to feature. I like to select things in the pattern. So I want to, what's the feature I want to pattern? I want to pattern the hole that we just added. The layout, I do want this to be circular because I want to pattern this in a circular pattern around the center axis of our part here. So when I go to specify vector, right, just like when we did the revolve, let's just say the same exact things it's asking, right? When we did the revolve, we didn't select an arrow and then the point. what we did with the revolve is we just selected the line, right? That works for us here too. The other thing, let me show you another thing that we could do. We have, this inside face of the cylinder. We also have the outside face of the cylinder. We could select either of those, right? Those are fine too. Because when we select one of those, what it does is it sees the vector direction, right? It sees the vector direction of this like positive and negative z, right? So it knows, okay, that's the direction of the cylinder. Also specifies a point. It picks the point up from the center of the feature that we selected. So all those are going to be fine. It just depends on what we have available and what makes the most sense. Also, we have the spacing, or the I guess I should say the angular direction options here. And the spacing options that we have are count and pitch, count and span, pitch and span, and then list. Just like with the flywheel that we did, where we pattern those holes in a circular pattern, same thing. So if we do count and span, we're specifying the number of holes and then the angular distance between them. Count and span will be the number of holes, or I guess a number of features that are being patterned, and then the total span distance, right? So the angular distance between the first and the last feature. Pitch and span is the pitch, the angular distance between them, and between each iteration, and the total span distance. So we're not specifying the number here, just the distance between the features and the total distance. We definitely want to say that the count, right? Because we want to be able to say, hey, 4 holes or 6 holes, whatever. And what we want is the span. So we want this to actually be, around this complete part. So we want it to be 360 degrees. So we'll do count and span. And on our drawing, we're told that we have 4 of these. So 4. And the span distance is 360. So if I say show results, I should see 1, 2, 3, 4 holes. And span distance of 360 degrees. So like if this did change to where it was 6, all we'd have to do is just update this to 6. And there's our 6 holes. We're going to keep it at 4 though. So we'll say 4. Now this last hole that we have is at the center of the boss that we added. And it is a threaded hole. It is a 3/8/16 TPI UNC. It does have a start chamfer of 0.375 diameter. So we do have a start chamfer. We'll go ahead and add a hole and choose our 3/8/16 TPI. So start hole tool. We want to change this to a threaded hole, not just a simple hole, but a threaded hole. Inch UNC size is going to be 3/8/16 TPI. So 3/8/16. Thread and gauge 0.75 is fine. Thread depth is full. We do want to add in a start chamfer. Make sure we have that selected. And once again, we do not need to go to our sketch section because we're just going to pick up the cylinder, the circle here, the center point of our boss. Make sure that when you're doing this, you're picking up the edge, right? The edge of the extrude, not the actual circle right here. So notice that this right here is below the surface of the, it's like sort of like in the center of it almost. What we want is the edge. So I'm going to approach the edge, make sure I snap to the center point of it. Now, if I do a through body, look what happens. It goes all the way through both sides. Let's see if that's what we want. That's not what we want. We only want this to go through an end. Okay. See what we can do about that. If I change this to a value, yeah, I could make it to where it's looks right. Make it where it looks correct. That's what we want, but it's not the way that we want to do it. Because if this were to change size, there could come a time where you don't have the correct length on size. Let's see if we do, if we do until next, that's what we're looking for right there. We want this to end, to go through essentially this side until it sees the cylinder. We could do until next. We could also do until selected and select the inside of the cylinder. And again, so it's going to extrude this hole up until it reaches the inside of the cylinder. So even if this were to change size, it's always going to extrude and end at the cylinder. So whether you do until selected or until next, either one will work just fine. And we'll say OK. Last thing that we'll do is we'll add in a couple of these edge blends here. So we have one around this part and the other around the boss and the other around the cylinder. So we'll come up here to edge blend. Make sure that we have this set to 0.1 inches. And I hit enter to lock it in. And we're going to select this line here. Again, edge blend just adds in the round. If we don't have a corner, like we're not doing this corner, if we have an inside corner, then it adds material. So notice that here's our actual edge right here, but it's adding this round to the inside. And then we're also going to select this edge. So not the actual like curve, or not the actual circle in the sketch, but the curve that it creates. We'll say now I can go in and I can go to view, show and hide, and I can hide these sketches in that datum and take a look at our pipe flange. And again, so editing this, updating this is rather easy. Let's go to my expressions. Our cylinder diameter, let's say our cylinder diameter changes from 3 to 3.25, just like in the other example that we looked at. Our boss is still centered on the flange there. Let's say that the distance here changes. So now it's 2 inches instead of just the 1.5, still centered. We change from 4 to a 6-hole pattern. No big deal. We'll change that to 6, and we'll say OK. And there's our pipe flange. So really easy to change, really easy to customize. It's not going to break our model apart just based off of a simple change. You can keep all those the same, 3 inches, that's totally fine. Make sure you save this part and upload it to the Dropbox on Canvas.